Good morning, everyone. It is great to see you all this morning. Happy Friday. And it is really my pleasure to introduce our seminar speaker for today, Dr. Mika Tosca. Dr. Tosca completed her PhD in Earth System Science in 2012 at the University of California, Irvine, and her postdoctoral work at NASA's Jet Propulsion Laboratory. Since 2017, she's been a professor at the School of the Art Institute of Chicago, where she primarily teaches science to art students. And in 2022, I think 3 months ago, or as of 3 months ago, she's a tenured associate professor there. In addition to her work investigating the links between climate and wildfire, she imagines ways that artists and designers can collaborate with climate scientists in an effort to better communicate and conduct climate research. She often speaks on the role of scientists, artists, and all of us in building post-climate change worlds, and is vocal about the urgency of addressing the climate crisis. I especially encourage all of you who are attending AGU, I guess either in person or online this year, to check out the plenary panel on art and science on Thursday that Mika will be moderating. I will steal maybe something from a seminar speaker a couple of weeks ago and encourage people to come fill out these first 2 rows. We definitely don't have a full house, so if you're comfortable with moving forward, it would be nice. I know Mika has some participatory elements for us that might be facilitated by being closer together. Right. These two is good, yeah. Awesome. And yeah, so without further ado, Dr. Mika Tosca. Thanks, everyone.
Thank you, Benjamin. I'm really grateful for that. Really, and you can hear me on the. It's very quiet. Should I move it closer to my mouth? Maybe, move it to the middle. I think it's on. Is this better? No. What if I just put it right like this? Okay, so I'll just carry it. It's a lot. There's a lot happening here. So okay, yeah. Thank you so much for the invitation to talk to you all today. I'm especially grateful for the invitation from Benjamin, who I've known for a couple of years now. We actually met at AGU, helping plan some of the sort of LGBTQ stuff. So it's been really exciting to come and see him at work in this setting. As Benjamin said in the introduction, I'm Dr. Mika. I teach at the School of the Art Institute of Chicago, which is an art university. All of our students are receiving BFAs in studio art, sculpture, painting, that sort of thing. But we have a really robust liberal arts department, which is an academic department. So we teach academic classes. So I teach science classes to students who are learning art or getting a degree in art. And so since being at SAIC, my practice, my research practice has sort of evolved from a past life looking at the interactions between wildfire and climate to thinking about ways that art and design can help us as we try to sort of tackle the climate crisis. So I titled my talk Solarpunk Futures. I'm going to be talking about a lot of different things, but the main thing that I really hope that you take away from this is optimism about the future and optimism in our ability to address climate change. That said, let's get the bad stuff out of the way. First, this talk is like an opera. It's divided into 4 parts. The first part is just some background. I think I'm sort of preaching to the choir here, but obviously climate change and global warming is really bad. It's at the temperature is rising at an unprecedented rate. And as we all know, this is due to human influence and specifically the burning of fossil fuels, oil, coal, and natural gas. This has resulted in hurricanes becoming perhaps stronger or longer lived, sea level rising, storm surge becoming worse, ice melting, heat waves expanding, all sorts of really fun stuff. And unfortunately, the projections into the future range from reasonably optimistic, no more warming, to a lot more warming. And this would result in sort of an increase in ocean acidity and a decrease in sea ice, land glacier, land ice, and sea levels. A bit of good news amidst the apocalypse warnings is that if you look at projected warming trends based on the policies that we've currently implemented in the last decade or so, it looks like we will only limit warming to maybe 2.5 to 3 degrees instead of the really apocalyptic 4 or 5 degrees. But it would be great if we could keep it below 2 degrees, which is considered catastrophic warming. And I think that there's a lot of cause for optimism that we could eventually do that. Unfortunately, this has led to a great deal of climate anxiety. My students are all Gen Z, and so I asked them if they could list some of their climate anxieties, and maybe some of these will resonate with you all. I'm not going to read through all of them. They're up there for you to read, but there's a lot of, I think, similarities maybe between the anxieties that we all feel and the anxieties that younger folks feel. There's anxiety about refugee crises and feeding people, and this one really resonated with me. One of my students said that one of their climate concerns is that as each coming generation is born and acclimates, they won't remember or even know a climate that was more stable or different than the one we're in now. So there might be really difficult inertia to overcome, since newer generations of people actually don't even remember a more stable time, a more stable climate. So how do we even begin to address this anxiety, this sort of like dire warnings of apocalypse? I want to start by asking you all a series of 3 questions. So for the first one, this is really easy, just a warm up. Just raise your hand if you think that you are a part of nature. Raise your hand. Okay, so I think that's pretty much everyone in here. Anyone think that they are separate from nature? Okay, so then just a show of volunteers for a word or two that you associate with the word natural. You can raise your hand or just say it out loud. Trees, water, air, organic, rocks. Okay, great. What about some words or things that you associate with unnatural? Plastic. Okay. Plastic. What else? Cars. Politics. Exactly. I was going to say politics. Asphalt. Okay. So there's a bit of a cognitive dissonance, right? All of us think we're part of nature, but when I ask you to list things that are unnatural, we list things that are made by and for humans. And when I ask you to list things that are natural, you list things that are not made by or for humans necessarily. So there's a big cognitive dissonance between us wanting to be a part of nature, but actually having rhetorically separated ourselves from nature. So even though we really long to be part of nature, we long for and yearn for a pristine, untouched wilderness, we haven't really, that's not really the case, right? We've kind of have separated ourselves from nature. And so I argue that we need to reimagine our future as one where nature and humanity can coexist, where we're actually a part of nature by redefining the boundaries between unnatural. And what better to help us imagine things than art. So this is part 2, where I'm going to talk to you a little bit about sort of the role of art as I see it in addressing climate change. And this will draw on my experiences, my pedagogical experience as a science teacher at an art university. So this graph on the right, I love. It was a poll conducted by the Pew Research Center, which asked Americans to describe how they see scientists. And 90% said they see us as intelligent, which is amazing. 40% say they see us as socially awkward, which is not as amazing. And only about 50% of Americans consider scientists to be good communicators. I think we all could probably find somewhere within us to acknowledge that we aren't exactly the most skilled communicators all the time. I think this is epitomized in the disparity between these 2 poll results. The top poll asked Americans whether they think climate change is happening or not. And fully 75% say that yes, it's happening, and only 10% disagree that climate change is happening. However, if you ask them why, only about 50% say that it's the result of human activity. So there's a solid contingent of Americans that believe climate change is happening, but not because of anything that we're doing. So there's been a failure in communication here, right? And there's an opening for expanding that. Did you have a question? Yeah. Both? All? I'll let you guys ponder that one. We will definitely address that, though. I agree that the media has a lot of fault here, can accept a lot of the blame. So that said, I think that when we talk about climate change as a thing, as an object, the well-known philosopher Timothy Morton, I don't know, have any of you read this book, Hyperobjects? No. So it's a great book if you're into reading about philosophy as it relates to climate change. So Timothy Morton describes climate change as a hyperobject, which is an object that's sort of too large spatially, temporally to really understand and describe, but we know that it's a thing. Climate change is a thing, but when asked to describe climate change, it's like a laundry list of things that are happening, right? So it's difficult to describe this singular object. So as a hyperobject, it's really an abstracted object. And while we all encounter abstractions in our work, right, that's what we do. As scientists, we're kind of finding ways to describe abstractions in nature. Artists and designers also in particular intelligently address abstraction every day and create objects. And so I think there's a really didactic role for art, which is epitomized by this show by Diane Burko, where she's making paintings of various climate change phenomena like glacier retreat or Amazon burning, etc. So here's the fun part where I get to show you some of the art that my students have made for me in my classes. And so this one is a great, my student titled this one, Climate Deniers on Vacation. You can see some really notorious climate change deniers. The Koch brothers, Scott Pruitt, Rex Tillerson, the former CEO of Exxon, sorry, sitting on, you know, charismatic megafauna, the polar bear, and then the background mountain relief is actually an abstraction of the carbon dioxide emissions to the atmosphere. Here's some more examples. On the right, this is a sample from a comic that my student made. They're from Florida and they're worried about sea level rise and all these sorts of things happening in Florida, right? And then on the left, this is a piece called White Pollution, where a student of mine strung those little packing peanuts together. Really horrible for the environment, right? Really, they're made from, what are they made from? Styrofoam. And they're blowing this fan at them, which is actually making this really beautiful noise. It's almost sort of calming to listen to, right? So there's a lot of drawing on themes of cognitive dissonance and that sort of thing. Here's another example on the left. This is a Nestle water bottle made out of glass. It's actually in the exact same shape of a plastic Nestle water bottle. And then of course, commentary on the plastic is that the bottle itself was what was used to make the koozie at the top of that glass water bottle. So it was used as the mold and then turned into a koozie. And then on the right, this is a video that one of my students made called Cake for Birds and Mothers. Along the Chicago shoreline, we have an endangered. Went out and researched the diet over, make the cake for the bird, put it probably compact, and then had sort of these captions all in the background. Probably not going to show the whole video all of the time, but you know, this is a really great example of, it's funny because Benjamin and I watched the whole thing. Okay, sorry. Anyway, so the video is 2 minutes long, so I'm just gonna skip it. Anyway, here's a video that a student of mine made. So Gen Z folks are really into collages. I don't know, it's like the art of the moment, it seems, collages. And so there's a lot of collage videos as well, which is found footage that's been put together. So I'm just gonna play this video. I'm not gonna say anything about it. I think it's powerful and I'm curious what you all think.
It's 1982. The National Weather Service has called this a once-in-a-thousand-year storm.
Washington State is having its worst fire season ever.
The city is now facing an unprecedented flood event.
This one, they're saying,
is the worst one yet.
It's 1982.
The National Weather Service has called this a once-in-a-thousand-year storm.
Washington State is having its worst fire season ever.
The city is now facing an unprecedented flood event.
This one, they're saying, is the worst one yet.
It's 1982.
The National Weather Service has called this a once-in-a-thousand-year storm.
Washington State is having its worst fire season ever.
The city is now facing an unprecedented flood event.
This one, they're saying, is the worst one yet.
It's 1982.
The National Weather Service has called this a once-in-a-thousand-year storm.
Washington State is having its worst fire season ever.
The city is now facing an unprecedented flood event.
This one, they're saying, is the worst one yet.
Okay, so I'm just gonna let that sit. I'm gonna let that marinate. I've got one more video for you, another one that's a collage of found footage. It's a video with commentary on the Hurricane Maria devastation in Puerto Rico. Many of you may remember when Hurricane Maria made landfall in Puerto Rico. There was extreme devastation, and the U.S. response was left a little to be desired.
Puerto Rico has been taken care of better by Donald Trump than by any living human being. I'm the best thing that ever happened to Puerto Rico. But Congress has given them $92 billion. Pakistan would like some of that, right? 92, not 1.3, because Pakistan was getting 1.3. $92 billion, and the money is squandered and wasted and stolen.
But $91 billion does not seem to be the correct figure, and we're not quite sure where the president got that. It is similar to figures for the total amount of damage to the island, so perhaps that could have been what the president was referring to.
I think that Puerto Rico was an incredible, unsung success. We are also praying for the people of Puerto Rico. We love Puerto Rico. Puerto Rico. And we also love Puerto Rico.
And I'll just leave that with no comment as well. And then finally, here's a few more examples. On the left, this is my one of my students made signs that they put up around Chicago describing the ozone hole. We talked about the ozone hole in my class, one of my classes. And then on the right, this is a fashion student who designed some post-apocalypse fashion, for example, heels that you could wade through Miami during a high tide or sea level rise in. But I want to pivot now and talk about perhaps an expanded role for art beyond just the communication of these difficult concepts, right? So I think that the work that I've shown already really speaks for itself. It evokes a lot of feelings and inspires a lot of emotion. But I'm now going to describe a project that I did that looks at the way that art can go beyond just communicating and also perhaps improve the way we actually produce scientific knowledge itself. And so it's a bit of a pivot towards design. So I'm going to be talking a bit about a design project that I worked on, where we redesigned a wildfire plume height data delivery system. And I would be remiss to begin a discussion on this without showing some work that one of my students made about wildfire. So for those of you who are unfamiliar or haven't really heard much or read much about wildfire, wildfire is you know, obviously something that's affected by both climate change and also different policies. For example, Amazon has experienced a surge in wildfire burning since the election of Jair Bolsonaro, who kind of loosened some of the restrictions that had been put on the Amazon. But wildfire is changing due to climate change and is occurring on every continent across the globe. This map from Sally Archibald's paper in 2017 shows where all anthropogenic fires occurred, and you can see that they're on every continent except Antarctica, although I have a colleague who has been recently studying fires on Greenland, and so it's possible that there will eventually one day be fires on Antarctica as well, as the world warms. And so in my past life, I mentioned that I spent a considerable amount of time studying the interaction between fire and climate, specifically trying to answer the question, how do tiny particulates, which we call aerosols, fundamentally alter the physics of cloud formation and the radiation budget? And the schematic that I've sort of come up with after 15 years of this type of research is that humans light fires, those fires emit smoke, that smoke gets into the mid layer of the boundary layer or the mid troposphere, where it absorbs radiation from the sun. This inhibits the formation of convective clouds, which dries out the surface even more, warms up the surface even more, and leads to a positive feedback whereby humans burning actually creates more burning. And there's a bunch of papers that I published on this, but the general mechanisms where we looked at the overlapping of two satellite tracks at the equator, and especially in equatorial regions, we found that increased mid-layer warming due to the absorption from the solar radiation from those fire aerosols is what caused an increase in subsidence, an increase in downward vertical wind, and a decrease in convection. And so the moral of the story is that landscape fires can change rainfall patterns and more broadly impact climate in important ways, and we need to know more. So during my time at the Jet Propulsion Laboratory, when I was working at the Jet Propulsion Laboratory, I worked on a satellite called the Multi-Angle Imaging Spectroradiometer, MISR, where we can use the fact that this satellite has multiple angles, multiple camera angles. Using a stereoscopic algorithm, we can estimate the height of various atmospheric features above the surface. So in this case, we were looking at the height of smoke plumes above the surface of the Earth. And so an example of this is shown on the right, where it's a little bit maybe hard to see, but you can see the coast here. This is the San Francisco Bay Area. And then you can see the smoke from those wine country fires from 2017 streaming southward. And so using the algorithm that we developed from this satellite product, we're able to estimate that that smoke was anywhere between, you know, half a kilometer to 2 kilometers above the surface of the Earth. And so we employed several interns over 4 or 5 years to create the MISR Plume Height Project database, where we have something like 15 to 20,000 plumes observed by our satellite, all the plumes that we could find between 2008 and 2013. Here's an example of the average altitude of wildfire smoke for all those plumes from the year 2009. You can see that the map itself matches Sally's map from a few slides ago, and that most of the smoke is being injected into the boundary layer or below, so 2 kilometers or below-ish above the surface, right? So we created this global database, and we hoped that people would use it. You can access it from a website that looked like this, which is a pretty bad looking website, I think. If you ask me, it's really difficult to use. It was definitely like made by a scientist for other scientists. And so no one was using these data. And so me being at an art school, I had at that point transitioned to the art school. And so I thought, what if we redesigned this whole project? What if we actually started from scratch and redesigned this project? And so we received a grant to redesign not just the website, but the whole database itself. And through the process of redesigning this website and this database, I learned a lot about how designers and artists make things. Specifically, the things that designers did that I found particularly captivating were that they incorporated things like understanding, actually talking to human beings about what they need, what they're looking for, what they're interested in with these data, with this project, etc. And sketching, lots of sketching, which I'll talk about in a second, and then lots of collaborating. Interdisciplinary, radically interdisciplinary, I would argue, collaborations across not just disciplines within science, but between art and science, and even, you know, the designers and engineers, computer engineers. So before we did anything, we began with a contextual inquiry where we tried to understand the people and the problem, right? So contextual inquiry is a design technique in which people are studied in their context of action in order to build a clear understanding of what they do and what they need. And so with this project, this entailed multiple interview discussions, and sessions and workflow demonstrations and sketching. So the designer that I worked with, Adrian Galvin, who now works full-time at the Jet Propulsion Lab, at the time he was still finishing his master's in design, but we got him a job at JPL after this incredible work that he did. He's also a brilliant sketcher. So these are all his drawings that I'm about to show. They're certainly not my drawings. And so Adrian and I talked a lot about sketching. How many people doodled when they were like in high school or middle school? Yeah, okay. So it turns out there's a lot of evidence that sketching and doodling activates the brain in different and perhaps better ways and causes like a higher retention of information. It just depends on the type of sketching that we're doing. And so sketching, if I had to define it, is a low cost and intuitive way to iterate on ideas, create artifacts that can be responded to and have conversations around. Ideas are created and thrown away, which saves effort, it saves cost, it saves time. So here are some examples of Adrian's sketches as we were describing, for example, the Miser satellite, which, I mean, this is just like beautiful. Honestly, Miser should put this on their website. And then as we moved into redesigning the interface, here are some examples of the initial sketches that Adrian made as we were thinking about what we might want and what might need to be thrown out in order to make this a really usable and robust redesign. And so we worked through the design process, which starts with an understanding phase, moves through ideation, prototyping, refinement, and materialization. And some of you might be thinking, oh, this isn't so dissimilar from the scientific method. And if you weren't thinking that, now you are, because I'm about to talk about why. I think they're kind of similar. But let me just walk you through what that looks like. So here's the beginning of a prototyping with a paper mock-up, and then we would test it, of course, with the scientists and with the users and with other folks, and then we did a digital prototype mock-up, right? And then another paper prototype, another digital prototype mock-up. All the while, we're co-designing with scientists. We're actually collaborating throughout the process, not just at the beginning, not just at the end, not just at sort of opportune moments, but throughout, showing sketches, sharing ideas, allowing the scientists and the designers to kind of get a clearer vision of what was needed and what could be used. As we were creating this novel visualization, right, it's difficult to imagine, I'm going to use the word imagine a lot, what it might look like, and only if we work in close collaboration can we ensure that we're on the right track. So let me show you the results. This finally went live at the beginning of this year after much bureaucratic wrangling from NASA and other entities. Keeping with a traditional NASA fashion, we gave it a absurd acronym. It's called Merlin, which I don't know, you can work out the letters. So just to remind you, this is what the website looked like. I guess you click that big search button in the middle, and that's how you find the plumes. Here is what it looks like now. So it's really stunning. And not only does it look pretty, right? Sure, great, it looks aesthetic, but it's also really usable. in that it tells me a lot of information without having to do any what I would consider science. So I don't know about y'all, but when I signed up to go to grad school and learn climate science and become a climate scientist, I didn't also sign up to be a computer programmer and learn 4 different computer languages. And so what this did, that was one of the big concerns that we brought up a lot, that having to code in Python and learn a new module and whatever takes away from the time and the brain space to actually do science. And so this eliminates a lot of that. Now you can see how many plumes, the average height of the plumes, the average radiative power, right? You can look at different XY plots right in the interface before actually downloading any data. So I can start to form my questions before I even download data and start working with this very cumbersome text file data, right? Here you can filter by biome, for example. And so I said we would return to this. So one of the big conclusions from this project is we started thinking about this scientific method and how it's both similar and dissimilar from this design process. So I know that we all know that the scientific method isn't this sort of linear thing where you have a hypothesis and then an experiment and an analysis and a conclusion, but it's sort of like this, right? That's why the arrows are circular. There's a lot of iteration between different steps, but it's not that dissimilar from the human-centered design process. So you have a hypothesis phase, which is very similar to the ideation phase if you're designing something, an experimentation phase very similar to prototyping, analysis similar to refinement, and conclusions similar to materialization of a design. But the difference, the glaring difference, is that there's much more emphasis in the design process put on this initial understanding step, right? So I often think that in this current post-enlightenment scientific endeavor project that we're all engaged in, we've kind of, I don't know, maybe lost a little bit of this type of empathizing, listening, learning from stakeholders. It seems a lot of times like we're creating science for other scientists, which is fine, right? But I think that doing this process and walking through this process with designers gave me a lot of insight into maybe ways that we could augment or modify or even just enhance a little bit the way that we think about and do science. And so you can actually read about this and some of my other art and science work in this paper that we published last year. I only highlight this because it's the coolest paper I've ever written, because it's a peer-reviewed science article about art and science. And people were super receptive to it. And it was just very exciting for me to publish something so sort of radically interdisciplinary. Like I've got some of my artist students on here and my designer as co-authors on a science paper, which is just really cool. So I recommend that you check that out if you're into it. So I want to conclude by injecting a bunch of optimism into the conversation and talk about this new work that I'm embarking on, which is we call sort of Solarpunk. Have any of you heard the term Solarpunk before? Okay. So Solarpunk is sort of like steampunk, except that instead of being focused on a dystopian future, it's kind of focused on not a utopian future, but a not dystopian future. Which is maybe helpful as we think about how we respond to climate change going forward. I want to start with some background. This is actually the opening paragraph from that paper that I just showed. And I'm only showing this for 2 reasons. One, how cool is it that I got to cite Octavia Butler in a scientific paper? I don't know if any of you have read Octavia Butler, but I highly recommend. She's a speculative fiction Afrofuturist novelist, and she often writes about the world that we build in the wake of environmental disaster. And one of her really oft repeated quotes goes, science fiction, and you could expand this to include all art, right? Is not just about solving the problems, it's not only about the problems of the world, but also about solving the problems of the world. Art can really help us solve problems, right? Our brains have probably been stimulated in ways today during this presentation that they're not always stimulated. And I think that that's really important as we think about the worlds that we're going to build. So this brings me to Solarpunk. Solarpunk is this emerging movement in speculative fiction, art, fashion, and activism that seeks to imagine and embody what a sustainable civilization looks like and how we build one, right? So the ideology itself contends that as climate change worsens, society needs more than just warnings, but society actually needs solutions, right? And it discards this apocalyptic framing that I deliberately started this talk with. It discards that, right? And replaces it with this post-nihilist paradigm for imagining a positive future. Hence the punk, right? The punk suggests that we need to center voices that are outside of the conversation and have largely been excluded, and think about the ways that we can address this crisis. And I hate this phrase, this turn of phrase, but outside the box, right? We need to look outside the box for solutions. And since I'm at an art school, I'm specifically focusing on Solarpunk style artwork, which has traditionally been expressed by blending the aesthetics of human technological ingenuity with the lush beauty of the natural world, similar to the sort of sprawling, luscious landscapes of Studio Ghibli films. I don't know if any of you have seen any Studio Ghibli films, but they kind of look like this. And so this is how I would sort of classify Solarpunk. So I just want to share in my last couple of minutes here 2 Solarpunk style projects that I've been working on with my students. So the first is this project, which is called Plastic City by my student Eli, where they imagined a world where in the future we're floating on plastic cities in the ocean. Do I think that's really going to happen? No, obviously not, right? But it's a really cool project because it incorporates all of these different ideas that we sort of learned about and that they did independent research on. So not only did they make a zine, for example, and a website, but they also made a whole techno music album. So they made a whole electronic music album and then music videos to accompany that. And everything was in the theme of Plastic City. And so this is on my website. You can actually listen to the whole album. It's on YouTube. It's so cool. It's really interesting. And it's all grounded in science, right? They didn't do any of this without first understanding all the science. We met for weeks and weeks and weeks and weeks on this. And then finally, I want to finish with this project that I've been working on with my student Javi, which I'm just so excited about, where Javi is painting a series of Solarpunk style paintings, oil paint on canvas. And the most recent painting, which I told him that he had to send me a photo of it by today so that I could show you all, is this one, right? And so now Benjamin's going to help me in the last moments that we have here, pass around some papers. We would love to know, so this painting is also going to be hanging at AGU. For those of you who are going to AGU this year, I've been really instrumental in a number of art and science projects. We're going to have an art and science on-site exhibition. We have a virtual exhibition, a community poem, and then I'm also going to be giving the plenary talk on Thursday. So I'm just wondering, as you look at this painting, what the first word or phrase or set of words comes to mind as you look at it. So as you're writing that down, if you would like, I want to conclude with this quote, again from Octavia Butler, which guides a lot of my work and my practice, and I think really centers the whole Solarpunk conversation. So this is from the Parable of the Sower, and I'll just read it out loud. It's really beautiful. The world is full of painful stories. Sometimes it seems as though there aren't any other kind, and yet I found myself thinking how beautiful that glint of water was through the trees. So I will conclude by saying this isn't the end of the world, but it could be the end of this world, right? This world that we've constructed. And that might not be a bad thing because we have this opportunity to make the next world better, brighter, and more equitable. But if we don't first imagine the future that we want, then we'll never have the future that we deserve. And we must incorporate diverse voices, diverse perspectives, and diverse approaches, which includes artists and others, to get us to the next world. So with that, I will say thank you, and I will take your questions and also leave it on the screen.
Okay, thank you so much, Mika. Do we have any questions in the audience or online for Mika? And Constantino has Eric turn around.
Eric. Hi, thank you for this inspiring talk. I really liked it. I want to refer to your last section about Eli's project. You said you emphasized that it couldn't be done without kind of really be rigorous about to couple it with an actual science. And this is always puzzled me. Where is the border, the fine line of border between staying accurate to the information or the facts and shifting from it to stimulate imagination and inspiration and without compromising? Where do you choose how to kind of weight those two?
That is a really great question. And I think that the answer is it depends on the context. So in many cases, right, like these projects are considered, I don't know, that my students and my collaborators who work on these would consider this fine art, and you're not supposed to put limits on fine art all the time. So this is something that actually we struggle with a lot. It's a really great question because I don't actually know where the boundary falls, right? Like, is something so unbelievable that you stop buying into it? Or is it just unbelievable enough that it gets you to kind of think about the parts of it that are believable? And then, so where that line is drawn, I think I maybe would leave that up to the viewer, up to the people who are actually looking at this. What I try to focus on is that it's not totally unbelievable. It's not a world that's not going to happen, right? So this isn't saying that the whole world is like water world, that everything has flooded. It's keeping with the consistencies of what we know about sea level rise, what we know about all the plastic in the ocean, and it's obviously kind of drawing on that. So there's a fantastical element that's rooted in like actual things that are going on. So yeah, it's a long way of saying I don't actually have that. I don't have an answer for you. I'm sorry.
Could you come back to the slide when you compare the scientific method with the artistic one? Yeah, so the scientific method, you know, when you test hypothesis and you reach conclusion, right? This is the deduction process. And after that, the conclusion usually leads to new hypothesis through the induction process, and it feeds again this whole thing. So can you also try to match this kind of cyclic scientific reasoning with the human-centered design process?
Yeah, I mean, that's a really good question. And I think that the human-centered design process also kind of does that as well, right? Like we're always redesigning our worlds as we kind of use things and discover that maybe this wasn't exactly the design that we wanted, and we return to the beginning as well. And I think, you know, in that way they are also continued to be analogous. But I would just say that that perhaps it might be helpful if we include a little more, and it doesn't, that's why I said it's not necessarily a linear thing. The understanding step kind of comes into play all throughout the design process, not as much as it might come into play during the scientific method process. And so I think there's ways of including it and still keeping that cyclical nature that you're describing. Yeah, thank you. I'm obsessed with this box being thrown.
Thanks, a fantastic talk. So NASA and NSF have been pushing a lot for open source science, open science. But one thing that frequently unites open source projects is the design is terrible. And beautiful data turns into, you had that great example of the website. So are there approaches to, you know, bring in science and design in a way that, well, gets the designers paid in terms of the proposal space and that sort of thing?
Yeah, I mean, that's, you kind of hit the real sticking point, which is the money situation, right? So a lot of art and design stuff is unpaid, just like a lot of work that we do as well is unpaid. And so, you know, how do we include designers in the open source sort of free conversation? I would say there's probably a lot of artists and designers that are also really invested in open source as a thing and would be willing to contribute their time or knowledge, or just like the scientists who are also doing it for free, you know? So every artist that I talk to about this problem, about this intersection of art and sort of environmental science, they say the same thing. They're like, we really want to be part of the process, and we don't want to just be part of the process at the end. We want to be part of the process in the beginning too. Talk to us about your project that you're working on, and we might actually be able to make it better, or at least help you think it through, right? But a lot of times we think of artists as being that thing that we can fill in the broader impacts, you know? Like, oh, we can do all this science, and then at the end, an artist is going to make a mural out of this, or an artist is going to like make our graphs pretty and put it on a website or something. But I think what I kind of try and argue here is that incorporating artists from the very beginning, which could include open source, which could include any scientific project, could ultimately result in a better outcome, right? And I think there's a lot of artists that are down for that. Where they kind of get a little hung up is when we do all of this work and then we're like, hey, can you like make this graph pretty for us? Here's like $20, or you know what I mean? Like, here's some money. They want to be part of the process, and then I think they wouldn't be so upset about the freeness of it, if that makes sense. Yeah, good question though. Yeah. Anyone else? almost.
Hey, thank you so much for this wonderful talk. It's so inspiring to see how you teach your students and how you centered them so much in this talk. And I'm trying to think like, you know, a lot of this is, you know, these are art students and you're teaching them science, and it's so inspiring to see how they're connected to the science. How do you think that's going to translate? Like, you know, we're teaching science students in a research institute, things like that. What do you think the opposite direction would look like? Do you think it's possible? What are the differences that may need to happen?
You mean like scientists interacting with artists and vice versa? Like you got like,
Yeah, like you ask a scientist to build an art project instead, you know?
Yeah, I mean, okay, so I have a lot of thoughts on this. Thank you for the question. Number one, if you look historically, art and science weren't actually this far apart as they are now. They seem to be really siloed disciplines, but so many famous scientists, well-known scientists, were artists. You know, the most obvious one that comes to mind, of course, is like Leonardo da Vinci, where you have art and science really working as the same thing almost, right? Like he's thinking of them almost as the same like discipline. And so I don't think it's that far-fetched for scientists to engage in art. I've given this similar talks, not this talk, but similar talks at lots of scientific institutions. And scientists are always like, oh, I love doing art and I want to do more of this. And it's like, you should. And I think artists would be really into it. And I think, you know, people are like, what's your suggestion? How do I do that? And it's like, I hate that the suggestion is like, go talk to some artists, you know, but if you're at AGU, you can meet some actual artists who are going to give some insight onto exactly what they want and what they need out of scientists. I will say at the school, the dean asked me, or like, I don't know, we won a grant sort of, I was sort of asked / she gave me a grant to create a curriculum that spans across all the departments. So across, again, our departments are like liberal arts, which is all the academic classes, and then like sculpture, ceramics, painting, drawing, new video, new media, film, blah, blah, blah. So it spans the departments and it aggregates all the classes together, and we call it art in the environment. We actually got like 50 students to sign up for it. We're doing a pilot next semester where they can take classes across these different departments, but with a common goal of doing art that's addressing the environmental crisis. And when I got to the Art Institute, I was like, I'm a scientist, these are artists, blah, blah, blah. And I've never been proven more wrong. Artists do research just like scientists do research. Artists think about things in really advanced and sort of like technical ways. And there's just so like, we have artists who are better computer programmers than I am, for example, right? And I'm a bad computer programmer, so that's not saying too much, but so, you know, so I guess what I'm saying is like, don't discount what you think you can do. I think we've been told that to be a scientist, you have to do science, to be an artist, you have to do art. But it's like, actually, are they that different? I don't know. I think that you should just, if you want to do art, incorporate art, you should explore that. Yeah.
Thank you very much. I'll preface my question by noting my daughter just graduated from SAIC. So I have real appreciation for art. She loves science too, so it's great. My question was, what about you know, artists in residence programs? It seems to me that would be an ideal situation where, you know, an institution, you know, just like we have Constantino to help us write for the public, we could have an artist in residence.
Absolutely, and that's a great suggestion. And more places are doing that. I don't know if this institute has one, but for example, like the Field Museum in Chicago has an artist and a scientist in residence. We also at the art school have a scientist in residence. So every year we hire a scientist who's usually on sabbatical or something like that to come and teach. And then lots of places like national parks have artists in residences now. A lot of the artwork that we're going to show at AGU was done by artists in residence. There's one artist at sea in residence who went on like a research cruise and just like painted ice. I know there's ice people in here. There's a lot of ice people, which is so cool. I think like that's just, you know, one of the coolest things. So I agree. Artist in residence is a great place to start. Artist in residence is like, you know, not that much investment for, I think, a lot of worthwhile output. Also, it's really funny that you say that your daughter just graduated from SAIC, because every time I give this talk, so many scientists like come out of the woodwork. Oh, my kid went to SAC. Oh, my wife does art on the side. Blah, blah. See, they're not that different. They're actually not that far apart, just say.
There's a question online.
The first question is from Marcy, and Marcy says, is your goal to reach a broader audience with art and Solarpunk? I understand that for certain people, art is a powerful method of communication, but I tend to not be one of those people. I often find the meaning behind art to be too abstract and thus meaningless. I hate to say it. So is that being considered how to reach a broader audience?
Yeah, I mean, the thing that an artist will say is that all art is not intended for everyone. And that's okay. All science is also definitely not intended for everyone. So I think some people, you know, painting it as no art affects me. I'm skeptical, but you know, that happens. But there's lots of different mediums, you know, like we encounter art, right? So working at an art school, the definition of art is probably a lot broader than y'all are considering art to be, or most folks consider art to be. Art can include like picking up trash in the park, you know, as long as it's like a performance. There's a lot of, I mean, baking a cake and filming it sitting at the lakefront and not a single bird came to eat it, which just cracks me up because it's like for this endangered species of bird, and then no bird came because the bird is endangered and there's only been one bird seen in Chicago, you know, in the last 2 years or whatever. But it's that kind of stuff. There's different types of art that reaches different people. There's visual art, there's sonic art, there's film art, and there's also just art activism, right? There's all kinds of different types of art. So yeah, art doesn't reach everyone, but I think that, you know, the broad definition of art as being something, you know, maybe visually or audibly or mentally stimulating in a different way is kind of what I'm referring to as art. I mean, museums have their own set of problems, right? Like museums have deep problematic histories and all kinds of stuff. And I often find museums to be the least accessible way to access art.
Speaking of which, Siobhan from the Blanton Museum of Art made a comment. She said, observation is one of the fundamental skills that both artists and scientists have in common.
Exactly. That's exactly it. Observation and abstraction, I think.
That's it for questions.
Okay.
Thank you so much for your talk. I really enjoyed it. Maybe token Gen Zer in the room, but I really love how you start with your talk coming from like the very like pessimistic view and then turning into something optimistic. And I often feel like within my generation, we just see no optimism. And so I'm wondering if you have any like tools, advice, observations within your experience to turn my work in science at the end of the day into something more positive, because I often feel like I'm always hit the wall. So
yeah, I mean, it's hard, right? Because there's a lot of ways to answer that question. So first of all, stop consuming. My one suggestion would be to stop consuming so much media, as the comment right at the beginning was, because the media really frames this problem as like an apocalypse, right? Like the human race is going to go extinct. I've seen a New York Times article that like the humanity is like going to go extinct. It's just, I find a really unhelpful way of framing this. Like we get it, it's bad. Like we've heard it's bad for a long time, and as those polls show, like most people agree that it is happening and it's kind of bad, right? So I guess like Solarpunk and others argue that we don't need any more warnings, we need like more solutions, right? And so the second part of your question, which was like, how do I express that in my work, is hard because there is the inertia of like the institution of science. I know we're all, you know, doing science. I have this unique situation where I was able to come and take a tenure track job at an art institution. So I have like the freedom to actually do this, whereas someone who's working for JPL or Goddard, like there's an expectation of what type of science. So broader impacts is always a good way to do it, and engaging just like outside of, you know, your normal scientific research period and normal people that you would normally interact with, like changing that up, talking to people who are in different fields. You know, there's probably an art program at UTexas, right? I would imagine, right? So, and I'm sure many people in there are concerned also about climate change. And I'm sure that you could go and talk to them, and I'm sure that they would be really willing to do something, you know, anything. This show that we're putting on at AGU, actually two of the folks who are exhibiting art are also scientists. One's a postdoc at UChicago, and then one is working in Ohio. I can't remember which university she's at. And they're both full-time scientists and also do full-time or do art as well. So I think there's ways to kind of link it. Maybe your own research is not going to be able to be framed in the most optimistic way. I don't know, you know, what your specific research is, but I think there's ways around this. And I think like just talking to people, getting different ideas is like a good way of thinking about it. Yeah.
Yeah, speaking about optimism, how optimistic are you that with art we can change the concept of the climate nihilist that you showed?
I think I'm optimistic. I've been giving this talks like this since 2019, and a lot of them were done over the pandemic. And every time I give it, it's like the attendance is better, more people are buying into it. And just this year, no, I think it's either NOAA or NSF. LO, I can't even remember, but I'm sitting on the judging panel for it. Is it NOAA? NOAA is doing they have a call for art, for climate change art. And there's an adult call and a youth call, and it's like this big grant proposal program that they're doing. And I know that I'm sitting, they asked me to sit on the jury for one of them. So I do think it's just changing. I have a friend who works for NSF, she's a program manager for NSF. They're trying to write more art and science into their grants and that sort of thing. So I do think it's changing. So I am optimistic. I also tell my students that if I'm not optimistic, what is the point of doing any of this for me? That's just me. That's my own personal perspective. But yeah.
Just related to that, there is a famous saying that no innovation made by pessimists.
Exactly. You can't build better worlds if you're pessimistic and sad and in despair all the time. Absolutely. 100%.
Thank you so much, everyone, for joining us for Dr. Tosca's seminar. Let's thank her one more time.
Thank you. Also, I brought my students make these zines as part of their project. So I brought some if you guys are sticking around for coffee and want to take a look at them. Also, I'll have them at the lunch for grad students and throughout the afternoon in Benjamin's office. So thanks.
You pass, leave the words that were inspired. I think Mika wants to share them with the artist.
I want to share them.